Okay, so today we're going to continue looking at regression. Up to this point, we've observed scatter plots and we've talked about association that we've been able to pick up on observing a scatter plot, and then we learned how to find the correlation of a set of data, of two variables by taking a set of data. And today we're going to begin looking at easier ways to do this now that we've mastered how to do this by hand. So you'll see I've got my calculator out. I would strongly suggest at this point that you go ahead and get one out as well. We're going to be using the TI-84 Plus in order to find the least squares regression line, or the equation of the least squares regression line. We're also going to find another side benefit, and that is a shorter method of finding the correlation of two variables as well. So all that said, we're going to start off by taking our calculator, and you'll see what I'm pressing here on the screen. We're going to go second, and we're going to go to the catalog, which is the 0 key after you press second. And this is the catalog of all of the available functions on the calculator. And you can scroll through very many of them, or actually you can even select the letter of the thing you want to select from the list. We are looking for a function called diagnostic on. We want the calculator to run diagnostics on the data that we enter. So we're going to select the diagnostic on button, and we will press enter, of course, and that's going to pop up here, and we will press enter again, and the calculator will let us know that it is done turning on the diagnostics for the calculator. So that said, now we're going to jump in to a problem, and you'll see on the screen I've got it pulled up here. Here's a problem that I've found. One factor in determining the shelf life of a dry cereal is the moisture content. Since standard packaging techniques do not completely prevent cereal from absorbing moisture, the longer it stays on the shelf, the more moisture it absorbs. A new cereal called Tops is being tested. We want to find the correlation and the equation of least squares regression line to represent the given data on the relationship between the number of days on the shelf and the moisture level of the cereal. So as you can see, I have an X variable, which we'll call our explanatory variable, and our response variable, the Y, will be our moisture level. So the first thing we're going to do is take this data, and we are going to enter it in the calculator. Okay, so now we're going to pull our calculator back out, and we're going to enter the data that was given there. Obviously, by this point, we probably know that we're going to press Stat and select Edit from the Stat menu. And this gives us the options of several lists that we can put data in. And I'm going to put the X values into list 1, and I'll put my Y values over here in list 2. I'm going to go ahead and pause the video while I go ahead and do that real quickly. In the meantime, I'll put the values back up on the screen for you. Okay, I'm going to pause the video while we enter those in the list. Okay, so if you haven't entered that yet, pause the video real quickly and enter these pieces of data into your calculator. And once you do that, you should have something looking like this. Obviously, we have 7 pieces of data. These are our X coordinates, and these over here in list 2 would be our Y coordinates. Once we have all of that set, we are going to now find the regression equation. If we wanted to look at the graph real quickly, we could set up our stem plot. I'm going to go ahead and turn this one on so we can see and I said stem plot out, I'm talking about a scatter plot. We'll select the scatter plot from the menu, and we already have the X list and Y list set to L1 and L2, so we're good to go there. Now we're going to quit that and look at a graph. This is not set up the way we want, so we'll zoom to fit the stats that we have. That would be zoom and option 9 from the calculator. And we can see our nice scatter plot here showing the values for the days on the shelf versus the moisture level in the cereal box. Now this does look pretty linear in nature, and it looks to be a pretty strongly correlated set of data. So we're going to go ahead and get an equation for this line. Now what we'll do next is we will go back to the stat menu, and we are going to calculate, and we're going to now scroll down, and I want to specify that we choose option 8 at this point. Don't be confused. Option 8 is very similar to option 4. For what we're doing in class, the form of the equation that we've been using in class is a plus bx. So we're going to stick with that here, and we will choose option 8, which is the linear regression of a plus bx. So we're going to select that from the menu, and we are going to make our x list, or our list of x variable data would be in list 1, and the list of y variable data would be in list 2. We are then going to store the regression equation in y1. Now, that is over here, when you press the y equals screen, you'll see a list of y values. We're going to want to have our equation put in there so it'll graph for us. The way we do that is we select vars, which is short for variables. We will move over to the y vars menu, and we are going to select a function. That function we select will be y sub 1 to start off with, and that is going to run the regression equation and put that equation in the calculator and store it in that spot. So if you don't have this menu or this type of setup, it's just a newer operating system, and some of you I know are using the older operating system for the TI-84, and that would be where you select option 8, the linear regression of a plus bx, and at that point you would put list 1, comma, list 2, comma, y1. It's the same information that you're putting in, it's just not as user-friendly. And once we do all that, we'll press enter, of course. Now, because we turned the diagnostics on this calculator, you see some extra information here. First off, we have y, and they don't put y hat, but it is y hat. Y hat equals a plus bx. In place of a, we can substitute in 2.9404, and in place of b, we can substitute in 0.0432, however many decimal places you want to add. That would give us our equation. So our equation in this case is y hat equals 2.9404 plus 0.0432x. And that would give us a great estimate of the equation. Now, looking at this, we'll continue on, and we can see here at the bottom, again, I mentioned because we have diagnostics turned on, we get the R value as well, which saves us a ton of time. As we all know, that calculating the R can take a bit of time to do if we do it by hand. Even using the calculator list functions, it can take a few moments. So we see that this function has an R value of 0.9926, which means it's a very strong positive relationship. Even when we look at R squared, which is something we've talked about recently, is the coefficient of determination, we see a 0.9853 value, and that means that we have a very strong linear relationship, and we can go and observe this over here. Now we'll go back and we'll look. Like I said, we stored this in y1, so when we go to our y equals screen, the y1 function has this equation in there. In fact, you can scroll over if you want. If you don't believe me, it's there. It has the full decimals in there. Well, not the full decimals, but rounded off several decimal places behind the decimal. So we get that there. Now, when we press graph, we get this, which is also a nice feature. Because we put that in y1, the calculator will graph it, and it's going to fit the data that we have. So we get a nice feel for how well this line that we've got is going to fit the data that we have. So going back to the problem, the original problem, it asked us to find the correlation and the equation of the least squares regression line to represent the data. And again, going back to our calculator screen, we can find that by looking at this. And I'll repeat the process again. Stat, calculate, and we're going to choose option 8. We're going to use list 1 and list 2 for our x and y, and we are going to store the regression equation by pressing vars, yvars, function y1, and we'll calculate that out by selecting calculate and press enter. So you can see your correlation again is 0.9926, and by using the A and B that it gives us on the screen here, our equation for the least squares regression line would be y hat equals 2.9404 plus 0.0432x. Simple enough. Just for extra practice, we're going to look at another problem now. If I can get the calc. There we go. All right, so a recent study has observed the relationship between non-exercise activity, abbreviated as NEA, measured in energy used in calories as the unit, and weight gain in kilograms of fat. So the data below show the findings from this study, and we want to find the correlation between the two variables that are given, and we want to get the least squares regression line to represent this relationship. So we'll continue on back to the calculator again, and we want to take a moment and enter this in the calculator. So I'm going to give you a minute to do that now, and what I'm going to try and do here is let you have a little bit of time to try this on your own before I show you on the screen what it should look like. But I would suggest at this point to go ahead, pause the video, and enter that data in the calculator. Okay, so I have now entered all of these pieces of data into the calculator, and you'll see over here, just to show you the versatility of the functions, I have elected to put the x values in list 3 and the y values in list 4 after using list 1 and list 2 for the previous problem. It's not really going to change the way this is done. It's just going to change the values that I type in to get my information. So I do have an equation back here in y1. That was from the previous problem. I'm going to clear that out. And we are now going to calculate, well, I'm sorry, let's take a look at the data first. Just to get an idea of what we should expect. I'm going to turn my stat plot on. Same thing, except now my X list is list 3. And my Y list is list 4. And this isn't entirely necessary, but I always like to take a look at the data in a scatter plot before we actually do the problem. And I'm getting ahead of myself. We should push zoom 9. So let's graph that again and zoom 9. Okay, so we see the data here. These represent our values that had a negative x on this side, and we can notice a downward trend here in the data, and that tells us that we should probably expect some type of possibly linear, more than likely linear data with a negative association. And it does look fairly strong. We'll get a good measure of it here when we find the correlation in just a moment. But that's what we're looking at. So let's go ahead now and do our regression for this data. So we go stat, and we are going to calculate. And again, we're going to bypass option 4 and go down to option 8. And we select that value or that option. Our X list, we said, was list 3, so we'll enter list 3. And our Y list is list 4, so we will enter that as well. We're going to store the equation. Don't forget to do that. That's an important part of what you're going to want to do if you're going to want to look at the graph later. And there are some other things that you can do once you get in there. So we're going to select Y1 again, and we'll put that in there. So now it's going to put our equation, after it makes the equation, it's going to store it in y1. So at this point, we'll press calculate, and we can see there's all the data for our equation. Our equation is y hat equals 3.5051 minus, notice that b is negative, so we'll say minus 0.0034x. And again, b is negative, that's our slope. Again, we noticed a negative association here, so we should be expecting a negative b, just like a negative r as well. Our r is 0.7786 for this data, and we get an r squared, of course, of 0.6061. So that means that roughly 60.6% of the variation in fat grams is due to this linear regression, or can be explained, not due to the linear regression, but it can be explained by the linear regression. So let's take a look. If we look at this on a graph, which is kind of cool, we can see there's our line passing through there. And, later on we'll learn some things about this. There might be some other issues to consider about this graph, but right now we see this, and the line seems to fit fairly well. And it gives us a good feel for how well the data fits the line. We'll continue again by answering the question. The question asked was, what is the correlation, or find the correlation between the two variables and the equation of the least squares regression line. So again, on the calculator, stat calc option 8. Again, it was list 3, list 4. We want to store the regression equation and y1, and we get all those values on the screen to show us what our equation is. You're substituting this value in place of a, so we'd have y hat equals, in place of a, we'll say 3.5051, and in place of b, we'll put minus or negative 0.0034x, and that gives us a good value, or a good equation, Our correlation value, which it also asked for in that problem, was negative 0.7786. Okay, so hopefully I've taught you how to save a little bit of time in using the Texas Instruments TI-84 to do this, to get the regression of a set of data. Again, don't forget, if you want to find the r and the r squared, or if you would like the calculator to do that, you must use the catalog function at the beginning and select diagnostic on. Just as a quick point, if you turn it off, which I'll do here real quickly, if we turn that off and do the same thing, stat calc 8, it's pretty much already set up, and we do the calculations, you don't get the r and the r squared there. Okay, so that wraps this up, and hopefully you'll get some opportunities to try this in class, and if you're having any other questions or concerns, hopefully we'll be able to address them there. Have a nice day.